everybody, welcome back. Today we're going to start talking about two new shortcuts to prove triangles are congruent. They're called angle side angle and angle side, and they are our new postulates. Before we get into that, remember, if you want to prove that two triangles are congruent, you have to prove that all of the sides are congruent, each pair, and each pair of angles are congruent. Unless you have a shortcut. We talked about two kinds of shortcuts yesterday. The two types of shortcuts that we talked about were side, side, side. If I can prove each pair of sides are congruent, I don't have to prove all those extra angles are congruent. Or if I have a side, an angle, an included angle, and a side, I can prove that they're congruent with just those three pieces of information without knowing all the other angles or sides. Before we get too far into our new shortcuts, let's talk about what an included side would mean. If you look at our picture right here, notice I have the segment JK marked. Now JK is between angle J and angle K. There's angle J and there's angle K. This segment is called the included side of angle JK. So what would be the included side for angle K and angle L in this second diagram? Segment KL, which is this definition is going to be useful to us going on. All right, so the angle side angle postulate says, and please take a second and pause this video and record the definition. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. And we abbreviate this with ASA. Well, what does that look like on my diagram? If I have one angle, and remember we mark angles with an arc. If I have one pair of angles that are congruent, let's name our triangles ABC and JKL. If C and L are congruent and B and K are congruent, then in order to be congruent by the angle side angle, I need the included side to be congruent as well. So what side would that be? On the triangle ABC, let's use a different color. If on triangle ABC, between angle B and between angle C is the segment BC. So this segment BC would have to be congruent to JL. And that would be congruent. Let's look at a different example, different triangles. If I have this angle congruent to this angle, and let's name our triangles again. ABC is congruent to, and we'll use the same letters, JKL. If A is congruent to J and C is congruent to L, what segment do I need to be congruent in order to use angle side angle? Between my two marked angles is the segment. So that is my included side. So AC needs to be congruent to JL. So I would say AC is congruent to JL. Angle A is congruent to angle J. And angle C is congruent to angle L. And so I can say by ASA, my two triangles are congruent. Now, what would that statement look like? Triangle ABC is congruent to, remember it's important to list your angles in order. So I chose A, then B, then C. A corresponds to J, so J. B corresponds to K, J, K, L. And that is the angle side angle postulate. Now we have a fourth type of postulate that we're going to learn about, which is the angle side postulate. So this is almost exactly the same. Take a second and pause the video. Write down this definition. All right. If two angles and one non-included side, so this time we're not including the side between, of one triangle are congruent to two angles and the corresponding non-including side of the second triangle, then it is congruent by angle side. Notice I'm using the same three letters, but in a different order. Notice the side is not included in between my angles like on this one. The side is included between my angles. So the order that I write those letters is important. All right, so let's look at our diagram. If I have, and let's label our triangles again, A, B, C, J, K, L. If angle B is congruent to angle K, that's my angle. Angle C is congruent to angle L, and we'll mark it with 2 arcs to show that those two are congruent. My side needs to be not included, so my included side would be between B and C, so AC is not included, and JL is not included. Now notice these are corresponding, meaning they're in between the two angles that correspond together. Now, I do want to show you, it doesn't have to be this side. I do have one other non-included side. It's this pair right here. So either this diagram or, we'll just mark it, or if I had these two red ones marked, I only need one because I only need two angles and one side, but this would work as well. So let's look at one second example. A, B, C. Let's get crazy. Q, R, S. All right, if I have angle A is congruent to angle Q, let's write down what we know. Angle A is congruent to angle Q. Angle R is congruent to angle B. Then what side should I mark? Remember, I have two options. As long as it is not the included side, we'll use a different color. I'm going to choose AC and QS. They are not included between A and B or Q and R. So AC is congruent, segment AC is congruent to segment QS. Notice I have two angles and a side, and the side is not included, so angle, side by angle, side. I know my two triangles are congruent, and here's my congruent statement. Triangle ABC is congruent to, remember to make these in order, triangle Q matches with A, R matches with B, and S matches with C. So here is my congruent statement, and I know that because of angle, side. Instead of having to prove all these other angles and sides are congruent, I can just use that shortcut. All right, let's look at some examples and see if we can determine from just a picture how I could prove that these triangles are congruent using my new types of shortcuts. So let's start with this diagram up here. Notice the information that they have marked is an angle and a side. Angle A is congruent to angle B, and segment AE is congruent to segment BE. So that is the information that they gave me. Now I need to find one new piece of information. Just remember all of our shortcuts. I only need 3 pieces of information to prove that they are congruent. So I am going to try and use one of my 2 new rules that I learned today. So either angle, side, or angle, side, angle. I already have one angle, I already have a side, so I'm looking for one pair of angles that are congruent. And if you remember from yesterday's lesson, when I have 2 triangles where I have two lines that cross, I'll use a different color. When I have two lines that cross and make a V, then I have what's called vertical angles. This angle right here is the same size and shape as this angle right here. And that again is they're called vertical. Running out of room. Vertical, pardon, I lost my L. Angles. And that means they're congruent. Now I can't call them both angle E because that doesn't give me specific information about what angles I'm talking about. So if I were to write my statements I need to write in order to prove that they're congruent, I'd start by writing angle A is congruent to angle B, segment AB, sorry, AE, my bad, I wrote that wrong. AE is congruent to segment BE. Noticing I'm writing B corresponds to A corresponds to B, so I'm writing them in the same order. And angle, now I want to do my one last angle, this angle right here. So I need to list it with 3 letters. Remember, your vertex or the middle point goes in the center of your order. So AED is congruent to. Now notice this isn't just a flip over this line right here. It's a rotation. So A is going to go to B, D is going to rotate to C, and E stays the same. So if I'm writing my congruent statement, I want to make sure that they correspond. So A corresponded to B. So triangle B, E is my middle letter. E stayed where it was. It didn't. So E goes to E, and D rotates to C. So angle AED is congruent to not triangle, to angle BEC. And I can write at the bottom of this by, okay, well, what information do I have? I want to make sure I can distinguish between the two. I have an angle, and I have a side. So here are my two options, angle, angle, side, or angle, side, angle. Notice the difference is where that side is. So I'm going to look at my side, this thing in purple right here. Okay, is it between two angles that I've marked as congruent, or is it not included between the two? Well, it is included between these two angles that I've marked as congruent to these two angles. So my option is by angle, side, angle, triangle. AED is congruent to triangle, and I can write them in the same order as I wrote my angles because I just already found out the order that they correspond. So AED is congruent to triangle BEC. All right, next example. If I have this diagram, notice this time I have 2 angles that are already marked. Okay, so what rule am I going to use? Which one of these am I going to use? I need to find a side that's congruent. Remember, if they share this side, it is called reflexive. And I can mark this as congruent. So I can write the statements angle O, which has 2. Nope, and we want to be specific about which angle. The angle O is the whole thing. So we're going to write angle, since O is my vertex, LO, and then it goes up to M. LOM is congruent to angle. Okay, this one also has the 2 tick marks. I started with L, which corresponds to N. So N, M is my vertex, so it goes in the middle, O. There's one angle. I got a lot of stuff going on here. I'm going to erase it. Okay, angle N corresponds to angle L, and there's going to be no confusion because it's not split up into pieces. So I can just say angle L is congruent to angle N. And last thing I'm going to mark is we marked this as congruent, so segment MO is congruent to, now if I write MO is congruent to MO by the reflexive property. So I can write my two triangles by, now I need to decide if I'm going to choose either angle, side angle. You remember here my two options, angle, side angle, or angle, angle, side. If I'm going to choose between these two options, then I've got to decide if my side is included between my angles. So if I come down here to my diagram, here's my side. Here's angle N and angle M for this triangle, this top triangle. Is that side between angle M and angle N? Nope, it is not included. So by angle, angle, side, not included, my two triangles are congruent. All right, two more examples and we'll be done. So if I look at this triangle right here, I just really want to quickly see which rule proves that these are congruent. Remember, again, I have these vertical angles that says these two angles are congruent. So I have angle O is congruent to angle M. Segment ON is congruent to segment, I have ON, so on this one I'm going to go ML because O corresponds to M, and that comes first. O comes first, so M has to come first. And my angle OPN is congruent to, O corresponds to M, so M first on my other one, angle MPL. And I'm going to say by, what rule are they congruent? Well, I have an angle, a side, and an angle, but I want to double check that side, whether that side is included. Here are my angles, angle right here, angle right here. Is this side included between P and O? No, it is not. So by angle, angle, side, these are congruent. And I'm going to say triangle OPN is congruent to MP, triangle MPL. Making sure that those are listed in the correct order. All right, last example, and this example is going to require one definition that you guys learned about last year in 8th grade. I'm going to review it really quickly. Here it is. Notice that this is a parallelogram. My opposite sides are equal, and this little arrow mark is telling you that these two sides are parallel to each other. Now last year in 8th grade, if two lines were parallel and you had a line cut those parallel lines, what occurred was if I had two angles that were on the interior of my parallel line, but on alternate sides of that line, they were congruent. So for example, these ones are already marked for you. These are alternate, and I'm going to write this down. These are alternate interior angles. But on the other side of this line, I also have a second pair. Okay, here's one angle. It is on the interior of my parallel lines, and its alternate interior angle that is also the same size is this angle right up here. So I can mark this with two arcs and say that those are also congruent. Lastly, remember when you have sides that share, it's reflexive and they're the same. So I want to determine how these are congruent. Well, I have two angles and a side, so my answer is either angle, angle, side, or angle, side, angle. But we're going to determine whether that side is included between my angles or not. So here's my side. Is it included between my two angles? Well, here's my green angle. Here's my blue angle that I just made green. Hey, is that side included between the two? Yes, it is. So my two triangles are congruent by angle, side, angle. And I can say that triangle RSQ is congruent to triangle. Remember, we are very specific as how we mark these. So if I started with RSQ to make this triangle, I've got to start with the corresponding on my second triangle. So the green angle corresponds to angle Q on my second triangle. So QS would be matched to P. If I reflected it over, or if it's a rotation more than a reflection, P and R. And there we go. That's it. Those are my two new shortcuts. And if you have any questions, please reach out to your teachers. You've got this.